This is the Daily Space for today, Friday, June 5th, 2020. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. Once upon a time in the early universe, in theory at least, there was a time when our universe was made of hydrogen and helium and trace amounts of lithium and beryllium. From this mixture, everything that we see today was formed, and among the first things to form, at least in theory, were stars made of only hydrogen, helium, and those trace amounts of lithium and beryllium. These chemically not very diverse stars are called population 3 stars, and people have been struggling to find them for decades. And the story of when they must have lived and died has gotten more and more confusing the longer we've gone without finding them. Here's some background you need to know for this story to make sense. In general, massive stars live very short lives, and the most massive stars live the most briefly, with some stars counting the years of their life in millions instead of the billions our sun counts them in. Tiny stars, however, essentially live forever, with nuclear burning hearts continuing to churn for trillions of years. Since our universe is aged in billions and not trillions, we would expect the most massive of the early stars to have died. But then we used to think the tiny ones should live on and on and on. But no matter how hard people look, no proper composition, truly lacking heavy element stars have been found. So we've updated our theories. Now we have added the caveat that folks think that stars made of pretty much just hydrogen and helium must be massive in all cases and thus short-lived in all cases. This means we are now trying to chase down exactly how massive and how short-lived those stars would have been. Instead of trying to search for old small stars in our current universe, we're searching for massive stars in time. Now, thanks to the finite speed of light, this is possible by looking at more and more distant objects whose light has been traveling for ever longer periods of time. So far, still no Pop 3 stars. They just haven't been found. And this is allowing us to narrow in on when they must have been. In the latest attempt, astronomers using the Hubble Space Telescope have been unable to find population 3 stars in data from when the universe was just 500 million years old. This means all the population 3 stars had already formed and gone supernova within 500 million years within the systems they looked at. This new work was led by the European Space Agency's Reshana Batswa-Decker and is published in monthly notices of the Royal Astronomical Society and is based on observations in the direction of galaxy cluster MACS J0416. This data was taken not just with Hubble, but also with Spitzer and the Very Large Telescope. The target of the observations weren't actually the stars in this galaxy cluster, but rather, this cluster's gravity was used as a lens to get a better view on even more distant galaxies that can only be seen when gravity bends light that would otherwise go off in other directions to instead focus in our direction, thus increasing the light we receive from these faint sources. This is a fairly old technique, but for this paper, they used new processing methods that allowed them to discover smaller lensed galaxies than have been seen before. I'm going to show you an animation that was distributed with this press release. It was hoped that these smaller systems might have slower star formation starts and may still have elusive Pop 3 stars forming and glowing. This was not actually found to be the case, so we now know with even greater certainty that these stars formed fast and died fast. And now more than ever, we have to admit our best option for finding Pop 3 stars will be the JWST if it ever launches. Space is hard. And understanding only advances in two ways: through major breakthroughs that require luck and creativity and training to recognize, and with the slow and steady advancement of better instruments that allow us to uncover details that had previously been just out of sight. Sometimes this slow and steady progress allows us to discover that is that a signal or is that noise blips in our data our actual signal? And this can be both satisfying and frustrating to folks who've spent decades trying to force discoveries out of too small telescopes. This is the case for the research of Fritz Benedict and Barbara MacArthur, who spent decades using telescopes of McDonald Observatory, the Hubble Space Telescope, and other missions and ground-based systems to try and discover planets by looking for on-the-sky motions of the stars. This technique has really only become possible now that we have the Gaia Space Telescope. But I remember hearing talks in grad school where Fritz was able to put limits on these kinds of planets don't exist, but these kinds could still be there. His targets were nearby stars like Barnard's Star and Proxima Centauri. Well, as we discussed recently, the Espresso instrument on the Very Large Telescope has used spectroscopy to determine there are planets. With this high-quality data in hand, Fritz has gone back through 25 years of Hubble data, something that reminded me I am old since I remember the first talks he gave. And in this data, he was able to see these now confirmed worlds in his noise. These were data points anyone could have used to say, there be planets. Sorry, these are data points that no one could have used to say, there be planets, not by itself. But it is enough to say now we can confirm the orbits with greater precision with this long baseline. And what's more, with today's new data, Fritz and Barbara and their team were able to find a new third planet in the Proxima Centauri system with an extremely long orbital period and a mass just 7 times Earth's mass. This story once again shows there's no expiry date on data. In general, we're pretty much over announcing every new planetary discovery. There are just too many of them, and it's starting to feel like saying, hey, that star has a planet is no more exciting than saying the Mississippi is flooding. Here in Illinois, where the river is flooding pretty much more often than it's not, we just pretty much ignore it. Now, sure, there is a weather alert, but does anyone really care? But yeah, sometimes the Mississippi is so high, everyone does need to sit up and take notice. And it turns out with exoplanets, sometimes a newly discovered world is so special, we need to mention it here on the Daily Space. Proxima Cyn made it in for being the closest star and having a really cool historical story about the discovery of its planets. Now Kepler-160 and its planet KOI 45604 are going to also make headlines. In this case, it's because we actually found a system I'm comfortable calling a fat Earth system. In a new paper in Astronomy and Astrophysics, a team led by Renee Heller has announced there is an 85% chance there is a 2 Earth mass planet orbiting in the habitable zone of a sun-like star. This isn't a red dwarf with an Earth-massed planet. This is a sun-like star with an Earth-like planet in its habitable zone. With a distance of 3,140 light years, we're not going there anytime soon. But I'd be satisfied with confirmation of this world and knowledge that a fat Earth is out there given big, beautiful, earthy possibilities. And that's all we've got. Dreams of other worlds. Thank you all for being here. I'm now going to stay around and answer your questions. And I have a whole lot of people I need to thank. Thank you, all you new humans. I'll thank you by name in just a moment. But first, I'd like to say I have been your host, Dr. Pamela Gay, and I wrote this episode. The web content for this episode will be produced by Beth Johnson, and the audio and video will be engineered by Ali Pelfrey. This show is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. So let's see what questions y'all have for me. And I just want to say thank you, Ilpin Who for the follow. Thank you, Veronica Cure, for the tier 1 community sub gift. Thank you, Sneaky Walrus, for the follow. Thank you, Stir Fried Crazy, for the follow. Thank you, Spooky23, for the follow. And Econ Greg, if you're still out there, thank you so much for the raid, and you keep on doing all the awesome educational streaming you do. And it's nice to know there's so many awesome voices out there. Those of you here in CosmoQuest that don't know Econ Greg should all give him a follow and check out his stream next time it goes live. All right, looking to see what questions we have in the chat. So Raj Luthra asks, which stars can last for trillions of years? Red dwarf stars. These tiny stars that can be, usually they're measured in hundreds of Jupiter masses. These tiny stars are basically one giant convecting blob of gas. With your normal star, you have the center, which is doing its nuclear burning thing, and then you have a zone around it that, depending on the mass of the star, is either radiating energy outward as photons try and escape, and then there's a convective layer on top of that that acts kind of like a heat lamp circulating material. Sometimes those layers get reversed depending on the type of the star, and that getting reversed, they just get rid of the radiative zone entirely in red dwarfs. Red dwarfs are constantly churning their entire outer atmosphere. And what this means is there's constantly new hydrogen getting carried into the core to undergo nuclear reactions. So the core can never run out of hydrogen fuel to keep burning until it's burned through all the hydrogen in the star. Every other kind of star is like, yeah, we don't do that. We're just going to, whatever we start with in the core, that's what we're going to burn. And then we're going to move on and burn things in shells moving outwards. It's this convective habit of red dwarfs that allows them to just go on and on and on in their burning. Let's see what else. So Henny asks, I wonder if the Alpha Centauri stars have overlapped Oort clouds. So the Alpha Centauri system is a 3-star system. Thank you so much, Tropical Tom. I have a doggo who heard that noise and came over to sit down ever so politely. One moment, and I will give you dog cam. I just need to switch my screen around. He was dead asleep across the room, and then he heard the noise and he's like, Mom, there. This is how we thank you for your bits, is we provide you cuteness. Doggo cuteness. Thank you, McKay, for the follow. Thank you. So the Oort system, the Alpha Centauri system is a system of 3 stars. We actually didn't know until fairly recently if Proxima Centauri was orbiting Alpha Centauri A and B. But we've now finally figured out, yes, it is. It is a 3-star system where Proxima Centauri is much further out from the other 2 Alpha Centauri stars. And as things orbit, the question becomes, well, how are they interacting with each other? I know Proxima Centauri is far enough from A and B that it wouldn't need to worry about having its Oort cloud really disturbed and overlapping. I don't know about the other 2 stars. I can look this up, though. Hold on. Yeah, dog cam's on camera. Okay, so the Alpha Centauri system is, come on, give me the geometry of it, somebody. Okay, I can't quickly find this while streaming. Let me try one different search. Distance between Alpha Centauri A and B is 23 astronomical unions. Oh yeah, those stars would either have a singular planetary system around them or just not be able to form planets. One of the things that we found is there appears to be these intermediate distances in binary star systems where you just don't get planets. If the stars are close enough together, you can get planets around the combination of the two stars. If the planets are far enough apart, you can get planets around each star independently at intermediate distances. And I suspect this is one of those distances, but I don't know for sure. It's much harder to get planetary systems. All right, let's see what other questions we had up earlier on. So Tropical Tom, the reason that I say JWST is I don't like to name people who had a troubled history with how they dealt with people of other genders and other colors. So rather than constantly bring up the name of someone who made it harder for some people to do their jobs just because they weren't white men, I'm going to say JWST. Sheila, I'm going to go with Sheila. Your name, I don't know how to say it. Writes, what is holding up JWST? I thought it was basically ready to launch. No, they put it together wrong. It was discovered when they did shake tests that a whole bunch of bolts came falling off, and this is a problem. And when they started going through, they found there's over 300 single points of failure. And one of the causes for some of those that they're still trying to figure out is they actually used the wrong kind of bolts in a whole bunch of places. And they now need to go through and figure out which bolts have to be replaced and which they can live with. The bolts they used just weren't strong enough. And then there are a bunch of other issues that we're just not going to go into. Basically, they did it, they finished it, they realized they screwed it up, and they didn't launch it. Yeah, that was a thing. Pump 3 stars. I wouldn't say that they're more elusive than cold fusion, but they rank up there. I think we're more likely to find pop 3 stars than to solve cold fusion. Welcome, Raiders. Fenimil, thank you for the tier 1 sub to Econ Greg. That's amazing, and that tells me Econ Greg is still out there in the chat. Pardon me while I scroll up to look for early questions before I scroll back down. Okay. The dog is like, hey, thank you, Ed Thompson, for the donation. Thank you so much. You are amazing, humans. You are amazing. All right. Scrolling back down, looking to see what questions came in at the end. The puppy's name is Malachi. He is a rescue that we've had for almost a year. This dog, when it first came in, was so beaten down and scared of humans that we pretty much had to keep him on a leash in the house because otherwise we couldn't catch him if we needed to. He's now to the point that he's like a smiling and happy dog. So yeah. So Hannes Vorverp asks, do most red dwarf stars fuse by quantum tunneling, or is most of the fusing normal? I have no idea what you're asking. Fusion in general requires electrons to tunnel between different energy levels. This is a completely normal thing in fusion. So I'm not quite sure what you're getting at. Not quite sure. So Veronica asks, do we have the ability to see back far enough to find tier 3? I think you mean pop 3 stars. Tier 3 would make so much more sense. Maybe it's more a matter of, can we find something that's gravitationally lensed that allows us to look back far enough. So until we do research like what I just discussed with a lot more galaxy clusters, we don't know if there's something out there that will be lensed enough that we can do this. Here we're relying on the universe to provide part of our instrument, and it's really hard to tell the universe where to point. Let's see what other questions we have in here. So Bad Panda Bear asks, for the Pop 3 star story, are they resolving individual stars or using the light of the whole galaxy to find the stars? They are using the light of entire small galaxies where you would expect different proportions of atomic lines to be visible based on what the overall population of the system was. We just don't have the ability to see individual stars, but doing population synthesis by saying, okay, if you have this mix of stars and this mix of stars, you see this. That's something we've gotten really, really good at. And we can test our ability to do it by looking at globular clusters. Well, that's actually a poor example. By looking at nearby tiny galaxies that have multiple generations of stars and synthesizing what all their light together would look like and then tearing it apart. And thank you, Adam, all together for the bits. I'm going to have to go get more Cheerios in just a moment. Hi. He's like, yes. And then he's going to proudly wear that Cheerio for a little while. All right. So, yeah, it's done via population synthesis. Wow, English is not my favorite language today. Let's see what else we have in here. Pardon me while I do the chat in a completely random order. So Sneaky Walrus asks, so are the suns burning or just releasing energy? So we use the word burning in the sense that they are undergoing nuclear reactions in their core. They're basically nuclear power generators. And they're in the process of transmuting different elements into heavier elements. Exactly what kind of transitions are taking place depends on the kind of star that you're looking at. So burning means releasing energy via nuclear reactions when discussing things in the context of normal stars. Language is trickstery. Let's see what else is in here. It's officially Puppy's Cheerios Day. Definitely a cause worthy of celebration. It is true, especially with a pupster. When he first came to us, he was about 15 pounds underweight. Okay, this is the last of my Cheerios, so I'm going to dole them out. Can you come here, Malachi? Come here. He's like, no, I don't want to stand. This is the laziest dog sometimes. He's like, no, just throw it. Okay, I can do that. All right, good boy. Yeah, he's totally oblivious to Cheerios when he's wearing them. His fur is so thick. Tom writes, our new alien overlords will teach us the secrets of cold fusion. I, for one, welcome this and our robot bodies. Oh, you and Fraser both. Fraser Kane is my co-host over in Astronomy Cast, and he definitely is looking forward to his robot body. Arthur says, someone asked earlier about stars forming in the first place. I couldn't find the name. Oh, so sorry, human. I didn't mean to miss your question. So stars form through the collapse of dense clouds of gas. Basically, if something shocks a cloud that is otherwise supported just by the bouncing around of atoms at a given temperature, it's the same gas law that you learned in chemistry in high school. It applies to clouds of gas. That's how they support themselves against gravity. But if something shocks that cloud so that it gets compressed enough that it's no longer in balance between gas pressure outwards and gravity inwards, it'll start to collapse, fragment, and spin. And in the process, you get stars forming as soon as the clouds of gas get dense enough and big enough, which, because of the gas law, makes them hot enough to trigger those nuclear reactions. Oh, that was Sneaky Walrus. That was me, was asking if there was some form of heat based on ignition of stars. So the nuclear reactions that are taking place, they release light, which is just energy, which is a way of getting heat, is you inject energy into a system. So the nuclear reactions are taking, for instance, two hydrogens, putting them together to form a helium, releasing light in the process, as well as neutrinos and things like that. And it's that light that is the heat that radiates away from the star. Thank you, Tropical Tom. Thank you. There. Econ Greg writes, we were talking about the sun, in particular the photosphere, chromosphere, and corona. Can you describe these so they don't have to lie next? So I don't have to lie next time. We were using my hydrogen alpha scope and looking at features in the chromosphere. All right, let me see if I can pull up. I'm now out of Cheerios. I can stand up and get more, but let me see if I can pull up a diagram of the sun. Images. There we go. Pardon me while I switch views. I'm going to replace the dog who's really wearing a whole lot of Cheerios with the sun. Yeah, that's the thing. All right, here we go. Here's the sun. So, easy way to remember it. Photosphere is where the light comes from. So photons, photosphere. Photosphere is where the light comes from. And so you see in this cutaway of the photosphere, you can see this is also where you can see the different temperature variations at the surface of the sun that are caused by, there's these really cool convective cells you may have seen. This is the granulation on the surface of the sun. Those are just blobs of warm gas rising just like in a lava lamp. The sunspots are places that are a little bit cooler in the surface of the sun where magnetic fields are coming out. And so some of the energy is instead streaming through the magnetic field instead of heating the surface of the sun right there. So above that, we have the chromosphere. This is the lower level where magnetic field effects really play a huge part. This area of the sun is a total pain in the butt to observe unless you go to outer space, because a lot of its light is coming out in the ultraviolet, which is blocked by our Earth's atmosphere. The chromosphere is where you have the solar flares taking place, where coronal loops loop up. It's the part of the sun that we all drew as little kids. We just didn't know that's what we were doing. Now, beyond that is the corona, which is extraordinarily hot gas that we're still fully trying to understand how it gets that hot. We think it has to do with magnetic fields in the sun releasing their energy at that high level in the atmosphere. This is a much more diffuse area. It's also only visible during solar eclipses because otherwise the rest of the disk's light drowns out our ability to see the coronosphere. There's a few instruments out there called coronagraphs that allow you to see it, but really even they block out the parts of the corona that are closest to the sun. And this is plasma streaking along magnetic field lines and flowing away from the surface. Does that help? Does that help? Ed Thompson asks, in your opinion, what was the greatest item of note from this week's AAS press conference? I'm not sure if there was anything that was sort of like, oh, wow, that was an amazing discovery. I think my favorite discovery was how the Fermi bubbles were formed by something so energetic that it illuminated and ionized the gas in the Magellanic Stream around the southern part of our galaxy. Yeah, it's just cool. You saw a huge loop today. Oh, that's cool. Our sun has been super quiet lately, so that was well-timed observing. Thank you, Econ Greg. Sunspot group of 12. Very nice, with huge loop in the southeast quadrant. We have a cloudy, nasty, rainy, awful day here. So normally I might use binoculars to project the sun onto a wall. But not today. Not today. And he's like, bubbles sound so gentle. So if you think about it, blowing bubbles with soap like we do as little kids and still as adults when we're pretending to be little kids and living our best life, by the way. Blowing bubbles with soap is super easy. Blowing bubbles with fresh chewing gum, not so hard. Blowing bubbles with really nasty old chewing gum, why are you chewing that, by the way? That's really difficult to do. As glass blowers learn, there's different temperatures of glass that allow you to blow bubbles with lesser and greater difficulty. In this case, they're blowing bubbles out of the material of our galaxy, so that requires a super energetic event. Not all bubbles are soft and gentle. So Sneaky Walrus says, what's this AAS conference and where can I watch it? It just completed, but all of the press conferences and many of the major sessions are available on their YouTube channel. One moment, and I will have that for you. There we go. So this is their channel. Please don't autoplay. Damn it, you're autoplaying. No, stop. Okay, there we go. So here we go. There is the channel. Hello, Annie. I didn't realize Binary Blaze was in the audience. They have a bunch of their material up here. It's not listed under uploads yet. You can find it listed under videos. Where did I find it? I may be lying. I found all the press. Oh, go to channel. I was lying. I didn't mean to be lying. Go to their channels. Go to press office. You can find all the press conferences under their press conference channel. Let me upload that. Sorry for the roundabout way of getting there. So this is all I've got for today. In an hour and 20 minutes, I am going to be back. I should be back. I always leave room for the universe to fall apart. To bring you Astronomy Cast with my host, Fraser Kane. This is our long-running podcast that we record live every week. Now, I'm not going to lie, I have completely forgotten what our topic is for today. So I'm going to look that up real fast. I know that they tweeted it for me. Exoplanet atmospheres. So we're going to be recording an episode on exoplanet atmospheres. live right here on twitch.tv and also on YouTube. This is a simulcast that we have been approved to do by Twitch because the show predates our Twitch channel. So come back. Thank you, Mythtown. All I have to offer is my dog even still in here. Hold on. Yes, the dog is still in here. Let me switch views. Switching views. There. All right. I'm going to see if he will come lick out the mug. It is only used for Cheerios. Hey, Malachi. All right. Malachi now has his snoot in the cup. Nope, he doesn't care. All right. Malachi isn't going to lick out the cup. He's just going to be sad. There he goes. Malachi is licking out the cup. Happy doggo. And I will wash the cup, dry the cup, and refill it with Cheerios. He does wear the Cheerio well. All right, so we will be back with Astronomy Cast in an hour and 20 minutes. For now, let me find someone to raid. Oh man, there's no one on my normal raiders list coming up. Anyone have any suggestions on who to raid? I need to add more people to our channel list. Let's see if I can find things somewhere else. We use a teleprompter. My teleprompter covers the very top edge of my monitor. So if I'm ducking under to look at things, it's because I can't read my tab labels. EJ doesn't. Why is EJ not showing up on my list? All right, I'm going to raid EJ. I'm very confused about why Twitch isn't telling me he's streaming. Twitch, why are you twitchy? There he is. Now I see him. All right, he's doing city skylines. Let's go build some cities, people. Let's go build some cities. So, as a reminder, this episode was written by me, Dr. Pamela Gay. Our content will be engineered by Ali Pelfrey, and our web content is produced by Beth Johnson. We are a product of the Planetary Science Institute, a 501c3 nonprofit. Our goal is to explore our solar system and beyond. We're here because of you. Your bits, your subs, your patronage at patreon.com/CosmoQuestX allows us to pay our staff a fair wage. And right now, your help more than ever really does matter. And if you're struggling, I get it. Don't give if you don't have anything extra to give. Thank you, human. Thank you. So we're trying to raise enough money that we can start to offer our part-time staff benefits. This isn't something that a lot of people can do, but we're hoping to. Now more than ever, it's important that people have benefits. We all currently have health insurance because we're all married, or Annie was a vet, which is a different case of a way you can get benefits. But we don't all have vision and dental and things like that. I just want to take care of my people. And I can do this with your help. So if you have extra to give, please consider becoming a patron of our show at patreon.com/CosmoQuestX. That's it. That's all I've got to offer. Be safe, people. The world is weird right now. Everything is trying to go sideways. Be safe. And do the best you can to live the best you can, wherever you may be in this world. And I'll see you on the other side. Bye-bye.